This video is about setting math formulas using LaTeX. It corresponds to section 7.9.2 of the Applied Analog Electronics textbook. Now, this isn't a full tutorial on typesetting math in LaTeX. That takes many videos. I'm only going to talk about some somewhat subtle points that students tend to miss when they've been following other people's videos or written tutorials even. What I'm going to do is I'm going to do some examples in Overleaf and talk through some of the little points that I want to make sure people get. So let's switch over to Overleaf and take a look. This is the input that I'm going to be using. What I did is I copied the template for lab reports that I provided on the web for Overleaf and gutted it entirely and replaced the main body with the LaTeX examples I've had here. So I changed the title, I changed the author. The preamble I didn't touch. So you can see right at the top there, for instance, I've still got the definition of the command ohm for doing the ohm symbol. All right, so what have I got here? Well, first piece of advice, no naked formulas. Every formula that you have in your reports must be part of a sentence. It's not a sentence by itself. It can't be just dumped in there and said, oh, equation 3, and then there's just equation 3 by itself as a naked formula. Cannot do that. You must always include it in a sentence. And grammatically, it's generally a noun phrase. So it can be the object of a preposition. It can be the object of a sentence. It can be the subject of a sentence, except for you can't start a sentence with an uncapitalizable symbol. So you can't usually have it as being the first thing in the sentence. It has to be buried a little bit in the sentence. It often ends up being the last thing in a sentence or the last thing in a phrase. Because math formulas are parts of sentences, they often have punctuation after them. Commas, periods, em dashes, all that sort of punctuation can occur after a math formula. And there are two types of math formulas that we have. We have inline math, where the math is just treated like any other word in the sentence and just formatted in line with the other words. Or we can have displayed math, where we take the math formula and stick it out on a line by itself. The punctuation doesn't change any if we display the math. So whether math is displayed or not displayed, the periods, the commas, everything are exactly the same, with one little problem. When we're doing inline math, the thing behaves just like an ordinary word, and we can put commas and stuff right after the math formula outside the formula. But if we do that with display math, the stuff that's displayed is put on a line by itself, and the punctuation would end up at the beginning of the next line, which looks awful. Punctuation needs to go with the thing before it, not with the thing after it. So what we do for display math is we stick the punctuation inside the formula. And generally we do that by putting a tilde, which is the standard unbreakable space in LaTeX, and then the punctuation symbol, the period, the comma, whatever it is, right at the end of the formula. And that's only for displayed math, not for inline math. Let's switch over to the output from Overleaf to see what those things look like. Okay, so at the beginning of at the end of the second paragraph here, I have v equals IR, period, and that period was outside the backslash open paren, backslash closed paren that enclosed the v equals IR. But the period for the 1/3 on the third paragraph, that is occurring inside the displayed math, so it occurs on the same line as the displayed math. And the tilde for unbreakable space in math mode. And notice also that note that the use of the tilde line here is not indented, it's not a new paragraph. Let's take a look at how that was achieved. The new paragraph occurs when you have a blank line. So to start the math formulas paragraph, there was a blank line before that. To start for display math, there was a blank line before that. But the note the use of tilde did not have a blank line before it, so it did not start a new paragraph. And You want to be in control of whether you're starting a new paragraph or not, particularly if your displayed math is in the middle of a sentence. You don't want to start a new paragraph in the middle of a sentence. So be careful not to put a blank line after displayed math unless you mean to start a new paragraph. Okay, important lesson here for punctuation is that the punctuation is normal for sentences. It doesn't matter whether the math is displayed or not. Incidentally, the same sort of punctuation rules apply for another sort of display you sometimes use, which is bulleted lists. Those bullets do not change the punctuation of the rest of the material at all. Displaying things doesn't change punctuation, does not replace punctuation. The punctuation still has to be there. Okay, let's look at some more formatting examples. Okay, so scrolling up here. Numbered equations. Quite often you want to refer back to the equations that you've introduced before, and you don't want to have to keep referring to them by some name that you gave them. You just want to say, oh, I want to look at equation 1, look at equation 3, if I combine equations 5 and 10. So if you want to do that sort of references, you have to number the equations. Except for you don't number the equations, you let LaTeX number the equations. The way you tell LaTeX that you want a numbered equation is you just say beginning equation, end equation, and then have displayed thing in between. That tells LaTeX to number that equation. Now, to get access to that number, you put a label on the equation. And here I've labeled it with EQN : Steinhard Hart. What that allows me to do is later on in the report, I can say EQN : Steinhard Hart, and that will expand to equation, whatever the number is, in this case probably equation 1. And if I introduce new equations, it doesn't matter, they'll all get renumbered by LaTeX, but the cross-references with the EQN : will be corrected automatically. Okay, some other points. Scalar multiplication in math mode, in math notation in general, is done by juxtaposition. Remember what I said, V equals IR? The I and the R were multiplied together. There was no symbol between them. They were just put down next to each other, and that made them multiplied. That's the standard way to do scalar multiplication. Don't use the cross symbol. That's the symbol for cross product of vectors, which we're not using in this course. So I don't want to see that. I don't want to see any cross products where you mean a scalar multiplication. That symbol for scalar multiplication, you stopped using that in 7th grade. So please, you're not in 7th grade anymore. Don't use that symbol unless you mean cross product of vectors. There is one exception. That symbol does get used sometimes as if it was a unit for a unitless gain. So if I have something where the gain of an amplifier is 20, I might write it as 20 with that times symbol after it as if it was a unit. But that's about the only case where I expect to ever see the times symbol in this course. Because juxtaposition means multiplication, that means in math mode we can't use multi-letter names. We can't have VREF, to mean a voltage that's a reference voltage, as a name for a symbol. Because if we just wrote VREF, it would come out as V times R times E times F, which isn't at all what we mean. What you do to get around that is to use subscript, V sub ref. And the subscripting is done with the underbar. And then in braces you put the thing that's going to be the subscript. And here notice I've used \mbox script size ref. And what that mbox does is say, make a box here using ordinary fonts. It's not math mode. And the script size says, make it the same size you would use for a subscript. And then you have the word ref. And that means you don't have R times E times F as the subscript either. You actually have the word ref as the subscript. It looks a little bit nicer. Okay. And speaking of things with subtle effects, when we're doing numbers and units, we want them to be treated as if it was a single word, so you don't have 2.2 on one page and PF for picofarad on the next page. That's really, really hard to read. So you want it to be treated as a single object, the number and its unit. But you don't want to run them together. And the best sort of compromise between those two is to put a thin space between them, and that's a \comma in LaTeX. And backslash comma is an unbreakable thin space, so that 2.2 backslash comma PF becomes 2.2 picofarads as a single object. And it either appears on one line or the whole thing moves to the next line. Same thing with 100 backslash comma ohm. The whole thing's a single unit, but not so crammed together that it looks crowded. The open brace, close brace after backslash ohm is a little trick to prevent backslash ohm from swallowing any following spaces. When you just have a command in LaTeX, if it doesn't have any braces after it, it'll eat up all the white space after it. And we don't always want that. In fact, we usually don't want that for things like ohm. So I've gotten into the habit of every time I type backslash ohm to put open brace, close brace after it. Here it wouldn't have been needed because the comma would have terminated it, so there wasn't white space. But I've just gotten into the habit of always doing the backslash ohm with open brace, close brace. If you have things with numbers and units and you want to multiply them together, again, you don't want to just run everything together. Put a thick space where you want a multiplication. And thick space is done with backslash semicolon. And so I've got an example we'll look at in just a moment that shows the difference between cramming everything together without the spaces and with the backslash semicolon and backslash comma for the thick space and the thin space. And finally, logarithms and trig functions all have their own special commands: backslash ln, backslash log, backslash sine, backslash cosine. And if you want to do log base 10, do backslash log and then subscript and then in braces the 10. Let's take a look at what some of these things look like. Okay, so we can scroll this up a bit. All right, the numbered equation, it did indeed get numbered 1. And when we refer back to it, it's equation 1 is the way it gets referred to. And that was set up in the definition of EQNREF that I put in the template. If you like to have a different thing like Formula 1 or EQ period 1, you can change the definition of EQNREF and all your cross-references will be uniformly formatted. Okay, there's the backslash time symbols that I've asked you not to use. And notice the difference between the vref and v times r times e times f, shown at the bottom of, I guess it's the third paragraph of this section. And the display math there, you can see 100 ohm, 20 picofarads all crammed together. Looks kind of awkward and hard to separate. But if you have the 100 ohms, 20 picofarads with the thin space before the units and the thick space for the multiplication, it actually looks reasonable. And you don't need to put in any special symbol for the multiplication. And the 2 nanoseconds there, again, there's a thin space before the nanoseconds. And you can see here that the ln, the log, the sine, and the cosine are all set properly and not as L times N or L times O times G. So using the backslash ln, the backslash log, gets those operators properly defined. All right, let's go back to the input again and scroll a little further here to look at fractions and parentheses. And we do a lot with fractions in this book. So we end up using the backslash frac operator for LaTeX quite a bit to make good-looking fractions with formula, horizontal bar, and another formula underneath. If you get embedded fractions with fractions inside fractions inside fractions, it can get kind of big. And if you just put little parentheses around it, it looks pretty silly. So LaTeX has a nice way of doing scalable grouping symbols. You can do backslash left, open paren, and backslash right, close paren, to make grouping symbols that scale up to be as big as the thing that they're grouping inside them. And we can take a look at what that looks like. All right, so there you can see the nested fraction with the silly little parentheses, which basically only are going around the horizontal bar at the top level and not around the whole thing. And then what I typed to get the backslash left, backslash right parentheses that are big enough to enclose the entire fraction. And I used the verbatim mode to get this thing displaying as a verbatim listing. Okay, there's lots more that you can learn about setting LaTeX math, and you're going to have to learn more than just this tiny tutorial. If you're having trouble finding a symbol, for instance, you know that there's some way of getting it in LaTeX, but you don't know what the command is to do it. Looking through the lists of LaTeX symbols, I mean, there are hundreds of pages of LaTeX symbols in different packages. There's a tool called Detectify, which can be kind of handy for saying, I know it looks like this, and having it try to guess what symbol you were trying to get. Okay, that's enough for this. Do look at section 7.9.2, which has a few more things in the book than I covered in this video.